You know, it's easy to think of the ground beneath our feet as solid, right? Permanent. But the truth is, it's constantly being rewritten. The world we see is just one page in an epic story of change. And that story, well, it's told using two completely different clocks. One ticks in the blink of an eye, and the other ticks over millions of years.
So let's start with that fast clock. Because sometimes the Earth doesn't exactly whisper when it decides to make a change.
It absolutely shouts. And there is nothing that shouts quite as loud as a volcanic eruption. I mean, just think back to the 1980 eruption of Mount St. Helens. We're talking minutes, and a colossal cloud of ash gets blasted 10 miles straight up, completely and forever changing the face of the mountain.
And the impact, it was just immediate and absolutely devastating. 57 people tragically lost their lives, and the property damage, over $1 billion. Just like that, in a single moment, a piece of the world was fundamentally reshaped.
But look, Mount St. Helens, as dramatic as it was, is really just one example of a much, much bigger system. See, forces like this are always at work, all the time, constantly shaping and reshaping our planet.
But that brings up a really important question, doesn't it? Does the Earth always change this fast, this violently? And the answer is, not even close.
And this is where we get to a really fascinating idea. Our planet basically runs on two completely different clocks. You've got the rapid, explosive events we just talked about, and then you have these slow, almost invisible processes that unfold over, geologic time.
All right, let's stick with that fast clock for just one more example. This is another one of those changes that can happen so fast you can barely even react.
I'm talking about a landslide. All it takes is gravity, maybe some other factors, and a huge chunk of a hillside can just let go. And in seconds, sometimes minutes, it buries or sweeps away everything in its path. So, check this out. Back in 1983, there was this massive landslide in Thistle, Utah. We're talking over a mile long. And it didn't just move some dirt. No way. It actually dammed up a river and in just a matter of days created a gigantic lake. Roads, railroads, the entire town, gone. Wiped right off the map. Thistle became a ghost town. That is the incredible, cascading power of rapid change. Okay, so let's hit the brakes and switch gears completely. It's time to look at the Earth's other clock, the slow one, the one that doesn't take in seconds, but in millions of years.
Think about this. That landslide in Thistle made a lake in just a few days. But the Himalayas, it's taken over 50 million years to build that mountain range. And get this, the process started when tectonic plates first smashed into each other, and it's actually not even done. The Himalayas are still getting taller right now as we speak.
So how in the world does that even happen? Well, the process is surprisingly simple, but unbelievably powerful. You have two of these enormous tectonic plates on Earth, and they're just pushing against each other. They've got nowhere to go, so the crust just buckles. It gets forced upward, millimeter by tiny millimeter, over millions and millions of years. And that is how you build some of the biggest features on the entire planet.
And this slow clock isn't just for building giant mountains. Think about something we take for granted, something totally fundamental, like soil. Yep, the very ground we walk on is the result of a mind-bogglingly slow process.
And when I say slow, I mean slow. This chart really puts it in perspective. Even in perfect, ideal conditions, you're looking at about 1 millimeter of new soil a year. 1 millimeter. In poor conditions, it could take thousands of years. So that rich topsoil that we need to grow our food, that's the result of centuries upon centuries of nature just slowly and patiently doing its thing.
Okay, so we've got these two clocks, right? The fast one and the slow one. But here's the really cool part. They're not working separately. They're constantly interacting with each other. And that interaction is what creates the world we actually see around us. Let's break down how this all fits together. If you map these forces out, a really clear pattern emerges. The super fast stuff, like a volcanic eruption, that tends to have a pretty local impact. A landslide is also fast, but its effects can ripple out across a whole region. Then, as you slow the clock way down to something like erosion, the impact is still regional, but now you're talking about carving out giant canyons over eons. And then, at the absolute slowest end of the scale, we're talking plate tectonics. That's when you see change on a continental scale. That's the force that literally builds the ground we live on.
So really, the next time you're out and you look at a mountain or a river or even just a field, try to remember this. You're not just looking at a landscape, you're reading a story. It's a story that has these explosive, really dramatic chapters, but also these long, quiet parts about slow, steady change that were written over millions and millions of years.
And you want to know the most incredible part of all this? That story isn't finished. It's still being written, right now. The exact same forces that created the world of the past are busy shaping the world of our future.
So what are the big takeaways here? First, our planet's surface is anything but static. It's always on the move. Second, these changes happen on wildly different schedules, from seconds to billions of years. Third, yeah, those rapid events like volcanoes cause instant catastrophic change, but it's the slow burn processes, like plate tectonics, that literally build continents. And maybe the most important point of all, the landscape of the future is being hammered out right now, today.
And that really leaves us with one last kind of mind-bending question to chew on. We've seen how a landslide can wipe a town off the map in minutes, and how plate tectonics can build a mountain range over eons. So knowing that both of those clocks, the fast one and the slow one, are always ticking, what do you think our planet is going to look like next?